in Deriver's review part 9, and yes, this does say part 2, it's a second review for you. Our first problem, find y prime of 2 if y is natural log x cubed. That means to take the derivative and plug in a 2. So y prime is equal to derivative of natural log 1 over, don't change the inside, multiply by the derivative of the inside. We could reduce that to y prime is 3 over x, so y prime of 2 would be 3 halves. Problem number 2, we have a product rule with chain rule. First function, second function. We want to do f times g prime plus g times f prime. So dy dx is equal to e to the negative 4x times derivative of sine is cosine plus the second function sine x multiplied by the derivative of e to the negative 4x, that's a chain rule, derivative of the outside, don't change the inside, multiply by the derivative of the inside. I would probably factor out the e to the negative 4x on this one. Dy dx is equal to e to the negative 4x. On the outside, inside would be cosine x minus, because that's a negative 4, sine x. In problem number 3, we could do this as a quotient rule problem if we want, or we could bring it up and do product rule. I think I'll do quotient rule this time. Dy dx is equal to square the bottom. We have bottom times the derivative of the top minus the top times the derivative of the bottom. So dy dx is equal to, these two x's are going to cross out, giving us 1 minus natural log x on the top, x squared on the bottom. Problem number 4, we have a product rule and a chain rule. Here's our first function and our second function. F times g prime plus g times f prime. So dy dx is equal to 2x minus 1 squared. The derivative of cosine would be negative sine, plus our second function, cosine, multiplied by the derivative of the first function, which would be 2x minus 1 times 2, because that's a chain rule problem. Try to clean this up just a little bit. We have dy dx is equal to, we could probably pull out a 2x minus 1. I'm not sure if I would do that or not. I've got 2x minus 1 squared. I've got a negative. I've got a sine x. We have plus a 4 times 2x minus 1 cosine x. I think I would probably leave it like that. I suppose we could if we wanted to factor out a 2x minus 1.